In this example, we have two towers that are 15 kilometers apart, and we want to find the distance from the water tower to the fire. So on our picture, let's label what we have. We have our ranger's tower and our water tower that is 15 kilometers apart, and then we want to find the distance from our water tower to the fire. So we want to find this line, and we'll label that as x. So to find the distance of x, let's see if we can use our tan, sine, or cos laws. Well, in order to use these rules, we need to have a triangle that has a right angle. And as we can see, this triangle is not a right angle triangle. So therefore, we're going to have to break down this triangle until we get a right angle. So how we want to break this down is we first want to start with this water tower at 97 degrees. We want to make a line that is going to be perpendicular to our line down here. So let's draw a dotted line from our 97-degree tower to the bottom. And then this will produce a 90-degree angle with the bottom line. So as you can see, we have our angle and we have a side length. So using these two, let's solve for our height. Let's label our height as y in the picture. So to solve for y, let's use sine, because sine theta equals opposite over hypotenuse, where our hypotenuse is 15 kilometers and our theta is 34 degrees. So plugging in what we know, we have sine of 34 equals our opposite of y over our hypotenuse of 15. Now to get y by itself, we want to cross multiply by 15, where these two cancel out, and we're left with 15 sine 34 equals y. Now plugging this into our calculator, we get y to be 8.388 kilometers. So now that we've solved for y, let's see if we can use this to solve for our unknown x. So looking at our example, we have a 97-degree angle here in the corner, and then we have our height of y. But this doesn't really help us because we need to know this angle here. We'll label that theta 1. So how are we going to find theta 1? Well, we know that this whole angle is 97 degrees, so maybe we can take 97 and subtract this little bit right here to get theta 1. So how are we going to find this little bit right here? Let's label that as theta 2. We know that all angles of a triangle have to add up to 180 degrees. So let's take our 34 degrees and our 90 degrees in the corner to solve for theta 2. So we know that 180 has to add up to all the angles in the triangle. So we have 34 plus our 90 degrees at the bottom plus our theta 2. Adding up the right side, we get 34 plus 90 to give us 124 plus theta 2. And then to solve for theta 2, we want to subtract 124 to both sides. And 180 minus 124 gives us 56 degrees as our theta 2. So now that we solve for theta 2, we can solve for theta 1. Because we know that the whole angle is 97 degrees, we can use that to solve for our theta 1 by taking 97 degrees and subtracting it by theta 2, which we found to be 56 degrees. 97 minus 56 gives us our theta 1 to be 41 degrees. So now that we have our angle and we have our height of y, we can solve for our unknown x. So on the side here, let's solve for x. But first, let's redraw our triangle. So we have our height, our hypotenuse, and our horizontal line at the bottom. Our height of y we found to be 8.4 rounded off. Our hypotenuse is what we were solving for, so that's x. And then our angle was what we solved for theta 1, so that's going to be 41 degrees. So we have an angle and we have a side length, so we can solve for our unknown x. So to do this, we can see that our angle is adjacent to 8.4 and the hypotenuse is x. So because we have an hypotenuse and an adjacent, we want to use cos, because cos theta equals adjacent over hypotenuse. Now we want to fill in what we know. We know that theta is 41 degrees. Our adjacent is 8.4, and our hypotenuse is x. Now to solve for x, we want to cross multiply and then divide by cos 41. So we have x equals 8.4 divided by cos 41. Plugging this into our calculator, we get our value of x to be 11.1 kilometers. So the distance from our water tower to the fire is 11.1 kilometers.